Ladies and gentlemen, to reaction. This is Wormholes Explained, Breaking Spacetime, or the channel Kurzgesagt in a nutshell. Are wormholes real, or are they just magic disguised as physics and maths? And if they are real, how do they work and where can we find them? Well, wormholes is one of those things that it is so advanced if it exists. I mean, right now, sure, theoretically and mathematically mostly we could see it happening, but we will not know until the time is closer. Right now they're way far away for us to even realize if it's real or just fiction. I guess we'll see. This is going to be a fun topic. I already did quite a few Kurzgesagt videos already. If you haven't seen them, check out the classes playlist I created for it, Kurzgesagt reaction or something like that. Check out the reaction too, like only sarcastic production, internet historian, CGP Grey, real life road, things like that, Tier Zoo. And yeah, let's watch this one.
If you saw a wormhole in reality, it would appear round, spherical, a bit like a black hole. Light from the other side passes through and gives you a window to a faraway place. Once crossed, the other side comes.
This just reminded me of all the Hollywood movies shows you this. Like in any kind of a movie or something, there's some kind of wormhole appear near you suddenly, somewhere like in a wall or at the floor somewhere or something. And person is always like, what is this? Let me check it. Let me check it out. Let me jump in it. And that's how shit starts always. And I'm like, how the hell do you do that? First of all, if you see suddenly wormhole appearing, you run the fuck away from it as far as you can. I mean, basically scientists and everybody, government people would, create a parameter around it, put red tape and things like the yellow tape, red tape, whatever. And then study it. Nobody would just jump in it. Oh, look at that. Let me jump in it.
For the interview, with your old home now receding into that shimmering spherical window.
Yeah.
But are wormholes real, or are they just magic disguised as physics and maths? If they are real, how do they work, and where can we find them?
Well, wormholes, let's just say, if you can consider wormhole as magic, like it's stupid, it cannot be possible, then just 100 years ago you would have thought that quantum physics is not possible, it's just magic. But it's not magic, it's here, we know it's here. It's really hard to basically understand or even observe, but it's here. So wormholes, it's not that far-fetched, even though it feels like that. I mean, bending the space-time completely, that feels a bit more dangerous. Like, you need two massive black holes just to create a ripple in space-time. You need black hole to bend space-time, massive gravity. You're going to bend space-time like, there are 100 or 200 million light years distance between galaxies or something. And then you bend those two point of areas in space together. You're gonna, basically close down the gap between these two galaxies, basically bend it like this and make them come together. Just so you could, go from one place to another faster. I mean, first of all, that would require immense level of energy, and even if you could do it, what if there is a repercussions, like maybe two galaxies basically attract each other, and the gravity of those two galaxies will make sure that that wormhole never closes, and it will just, start to collide with each other. Who knows what's gonna happen? This feels really dangerous.
For most of human history, we thought space was pretty simple, a big flat stage where the events of the universe unfold. Even if you take down the set of planets and stars, there's still something left. That empty stage is space, and it exists, unchanging and eternal. Einstein's theory of relativity changed that. It says that space and time make up that stage together, and they aren't the same everywhere. The things on the stage can affect the stage itself, stretching and warping it. If the old stage was like unmoving hardwood, Einstein's stage is more like a waterbed. This kind of elastic space can be bent and maybe even torn and patched together, which could make wormholes possible. Let's see what that would look like in 2D. Our universe is like a big flat sheet. Bent in just the right way, wormholes could connect two very, very distant.
Yeah, basically, I've seen that Joe Rogan's basically podcast with Neil deGrasse Tyson, in which he just, I don't understand gravity, and maybe Neil deGrasse Tyson was having a bad day at that time or what, he didn't explain it properly or he didn't say the right words. he was getting annoyed a lot. Maybe he had a bad day, long day, who the fuck knows. But that's the thing with, I don't understand gravity. What do you mean by you don't understand gravity? We know how gravity works. If you're asking why is there gravity, like why question is basically always unanswered. Why is there gravity? Why is there anything rather than nothing? Why is there a space-time? Why is really hard to explain. How we can do it. How things are. I'm talking about at the core of things. I mean, when you explain something, then go deeper inside, then explain something, you go deeper inside, then explain something, then go deeper inside. There will be a point where you come to the origin of things. And in that, it will be really hard to explain the why things exist like they do. So as far as gravity, it's not that hard to understand, man. Like if you imagine 2D, you can imagine basically a bed sheet. Where you put if a massive heavy ball like bowling ball, it will curve things around you, around the ball. So that's how gravity works. And you think like, what does that even mean? It's not 2D, it's 3D. I mean, we are not all sitting on a seat. We are surrounded by space-time. Well, fish are surrounded by water. This is similar than that. But imagine in water, if there is a heavy thing, it basically bends it in 3 dimensions, like bends it inside. That's how gravity works. So it's not really that hard to understand. But if your question is why is there gravity, why is there all the Newtonian physics, why is there laws of physics, why is there space-time to begin with, why do we need space-time as a thing rather than just staying in something empty, why is that really hard to explain?
Distant spots with a short bridge that you could cross almost instantaneously, enabling you to travel the universe even faster than the speed of light. So where can we find a wormhole?
Yeah, see, the thing is, this is explained in 2-dimensional. But in 3-dimensional, there is no gap between these two things if you bend it. So that's what I'm thinking, that if you bend 2 places, like 2 galaxies together just to go to another galaxies, there won't be a gap because this is not 2 dimensions, it's 3-dimensional world. So if you close them together, what if 2 galaxies collide? And I guess ruptures or basically does something to space-time that it cannot go back to what it was like, and just basically 2 galaxies collide because of that. I don't know, it feels dangerous. Maybe we can do it. If we can do it, it would be awesome. It would require immense level of energy because bending space-time is not a joke. But yeah,
it's even faster than the speed of light. So where can we find a wormhole? Presently, only on paper. General relativity says they might be possible, but that doesn't mean they have to exist. General relativity is a mathematical theory. It's a set of equations that have many possible answers, but not all maths describes reality. But they are theoretically possible, and there are different kinds. The first kind of wormholes to be theorized were Einstein bridges. They describe every black hole as a sort of portal to an infinite parallel universe. Let's try to picture them in 2D again. Empty space-time is flat, but curved by objects on it. If we compress that object, space-time gets more curved around it. Eventually, space-time becomes so warped that it has no choice but to collapse into a black hole.
Oh hey, I know you.
It's awesome to see how even this can be explained by the bed sheet. I mean, if you're lying on your bed, you would create less of a, bump and curve than if you're just standing on 1 foot on your bed. That would create even massive bump and massive curves. So yeah, that's just how it is. When you shrink basically a thing down, but the mass stays the same, obviously it's gonna curve more and more.
A one-way barrier forms, the event horizon, which anything can enter, but nothing can escape, trapped forever at the singularity at its core. But maybe there is no singularity here. One possibility is that the other side of the event horizon looks a bit like our universe again, but mirrored upside down, where time runs backwards. In our universe, things fall into the black hole. In the parallel universe with backwards time, the mirror black hole is spewing things out a bit like a Big Bang. This is called a white hole. Unfortunately, Einstein-Rosen bridges can't actually be crossed. It takes an infinite amount of time to cross over to the opposite universe, and they crimp shut in the middle. If you go into a black hole, you won't become the stuff coming out of the white hole. you'll only become dead. So, to travel the cosmos in the blink of an eye, humans need a
Yeah,
different...
you would reach singularity, then time just passes like that. But yeah, I mean, it could be possible that maybe there are multiverses where, you could think like, there are best shit over best shit that basically touches each other, and something like really, something that could bend space-time really hard, like, black hole does, and basically cause some kind of rupture. You could basically go to the another sheet, like another universe. Maybe that could happen, but then again, the time is, incredibly, like he said, infinite time. So I don't know.
different kind of wormhole, a traversable wormhole. If string theory, or one of its variations, is the correct description of our universe, then we could be lucky and our universe might even have a tangled web of countless wormholes already. Shortly after the Big Bang, quantum fluctuations in the universe at the smallest scales, far, far smaller than an atom, may have created many, many traversable wormholes. Threaded through them are strings, called cosmic strings. In the first billionth of a trillionth of a second after the Big Bang, the ends of these tiny, tiny wormholes were pulled light years apart, scattering them through the universe.
When you would see something like that, your first thing would be, come on, there's no string between two places. I mean, you don't even detect those strings. What if you're traveling and hit one of those strings, and this simpleton type of mentality? But if you think like that, I mean, that would be like commonsensical thing, like, come on, there are strings attaching two places. But then again, like I said, quantum physics is ridiculous, but it exists. There's somebody who did an experiment, I guess in Geneva or somewhere, where they shot two photons, from in opposite side. Group of photons from the opposite side. One went that way, one went that way, and then obviously it was so far away that they thought that whatever they do would be their individual thing, and we won't be able to basically communicate with each other because they were far away. But every time they did their experiment, both of the photons did the same thing, faster than the speed of light. That should be impossible. Like they were somehow communicating with each other faster than speed of light. This is two photons experiment or something like that, and that was spooky as hell. That's basically spooked people, and people start to think maybe E equals mc square. There is modifications to that. Maybe we need to discover more things, because quantum physics basically does things that normal laws of physics doesn't make sense. So when you have things like that, I mean, your common sense of thinking like, come on, there are strings between two places, that's stupid. But it's not really. I mean, it could be. Quantum physics tells us that saying something is stupid itself. I mean, this could be.
If wormholes were made in the early universe, whether with cosmic strings or some other way, they could be all over, just waiting to be discovered. One might even be closer than we realize. From the outside, black holes and wormholes can look very similar, leading some physicists to suggest the supermassive black holes in the center of galaxies are actually wormholes. It will be very hard to go all the way to the center of the Milky Way to find out that.
So like how you play some video games in open world games, and if you want to go from city to city, there's a fast travel station in the center of the city where you have to go through to go to the next city. Why would you travel all the way there on foot, where you can fast travel? So basically, between galaxies, there's nothing there. Basically, close to nothing there. And these galaxies are the thing where everything is like stars and planets. So basically, every galaxy's center, there's a fast travel point. Is that it? That would be so funny though.
But that's okay. There might be an equally extremely hard way to get our hands on a wormhole. We could try to make one. To be traversable and useful, there are a few properties we want a wormhole to have. First, it must obviously connect two distant parts of space-time, like your bedroom and the bathroom, or Earth and Jupiter. Second,
look, I'm not gonna lie, if you use a wormhole just to go from your bedroom to bathroom, I think that should be a crime. You use wormhole just for that shit?
it should not contain any event horizons which would block two-way travel. Third, it should be sufficiently sized so that the gravitational forces don't kill human travelers. The biggest problem we have to solve...
That's the thing I'm thinking of. Even if there are wormholes, there's a high chance we are not strongly bound together compared to the cosmic things. So humans coming out intact as we are from the other side is extremely unlikely. So even if there are wormholes, we might not be same. There might be pile of goo coming out from the other side. That would be so effed up.
Is keeping our wormholes open. No matter how we make wormholes, gravity tries to close them. Gravity wants to pinch it closed and cut the bridge, leaving only black holes at the ends. Whether it's a traversable wormhole with both ends in ours, or a wormhole to another universe, it will try to close unless we have something propping it open.
Star Trek, I think it's Star Trek, right? I never saw much of that, but I know there's one thing where it's like this wormhole where you basically, teleport. That is like a wormhole or something where literally you get, ripped apart from the molecule level and reassembled at the other side. And, that's also scary to me because how do you know that's you and not copy of you? How do you know every time you basically teleport, you dies and the other side there's copy of you that thinks that's you because it has everything from you, every copy of you, even the memories. So it would think that that's you because everything would be exactly just the way you were before you teleported, even the memory, feelings and everything. So it would think that that's you, but maybe you just died because you were ripped apart from the molecule level. That Star Trek thing basically, give me jitters, like what the fuck? Because if things like that come to be, I would never use that. Because how do you know? Consciousness is really hard to explain. How do you know that that's you? How do you know that's not just copy of you and you just died? That's just effed up. Same thing with that TV show. What was that? There was a latest TV show. I forgot the name, where you upload basically your consciousness to a server. And whenever you die, you could just create your copy of a body and upload your consciousness there so you live on. How do you know that's you and not copy of you and you just died? Because you're copying things that is you. You're copying your consciousness. So it could be perfect copy of you that thinks that it is you, but it might not be you. I mean, it's just weird.
Very old string theory wormholes, that's the cosmic strings job. For man-made wormholes, we need a new ingredient: exotic matter. This isn't anything like we find on Earth or even antimatter. It's something totally new and different and exciting with crazy properties like nothing that's ever been seen before. Exotic matter is stuff that has negative mass. Positive mass, like people and planets and everything else in the universe, is attractive because of gravity. But negative mass would be repulsive. It would push you away. This makes a kind of anti-gravity that props open our wormholes. And exotic matter must exert enormous pressure to push space-time open, greater even than the pressure at the centers of neutron stars. With exotic matter, we could weave space-time however we see fit. We may even have a candidate for this exotic matter, the vacuum of space itself.
I think it's not just that, Brian Greene was basically saying, is this, string theory scientist. So he was once saying in a podcast, like, if there are ruptures in space-time, like rips in space-time, which there could be if you're creating a wormhole, then space-time, acts like a band-aid that basically, try to stitch it together slowly with strings. Basically, like it's some kind of a band and try to shut that hole down. So maybe, forcing the hole to be open is going to be hard when space-time itself is trying to weave itself together and close off, like a band-aid, or how your skin basically heals itself. So if that's the case, that would be really hard to, basically keep the wormhole open.
Quantum fluctuations in empty space are constantly creating pairs of particles and antiparticles, only for them to be annihilated an instant later. The vacuum of space is boiling with them, and we can already manipulate them to produce an effect similar to the negative mass we're looking for. We could use this to stabilize our wormholes. Once we're keeping it open, the ends would start together, so we'd have to move them around to interesting places. We could start by wiring the solar system, leaving one end of each wormhole in orbit around the Earth. We could fling others into deep space. The Earth could be a wormhole hub for a vast interstellar human civilization spread over light years, but only a wormhole away. However, wormholes have a dark side. Even opening a single wormhole kind of breaks the universe in fundamental ways, potentially creating time travel paradoxes and violating the causal structure of the universe. Many scientists think that this not only means they should be impossible to make, but that it's impossible for them to exist at all. So for now, we only know that wormholes exist in our hearts and on paper in the form of equations. We know you want to know more about universe stuff, so we're trying something new. Kurzgesagt.
I mean, just because there's paradoxes doesn't mean the universe is going to say no to that. There is no hard wall like that. I mean, if it can be possible, it might work. It might cause lots of issues, like he said, but it doesn't mean that it can't happen just because there are paradoxes. I mean, quantum physics basically tells us that, all the physics that we know of and all the paradoxes that we might think doesn't matter when it comes to quantum physics, like two photons communicating with each other instantly at the way faster than speed of light. I mean, that should be impossible, but that's happening. So yeah, who knows? Alright people, go to brilliant.org / nutshell and support this channel. This was a great video. I love whenever a deep scientific topic like this comes. God, I hope there's a wormhole in the future. It would be so awesome. But any of us won't experience it, so it's sad in its own way. But yeah. Alright people, if you like my reaction, do like and subscribe. Check out the reaction I did. There's a link in the description. Check out the cards for the playlist. Check out the end cards, and I'll see you next time.